Semiconductor diode. The behavior of the p-n junction with regards to the potential barrier's width produces an asymmetrical conducting two-terminal device better known as the p-n junction diode. A p-n junction diode is one of the simplest semiconductor devices around and which has the characteristic of passing current in one direction only. However, unlike a resistor, a diode does not behave linearly with respect to the applied voltage, as the diode has an exponential current voltage IV relationship. A p-n junction diode is symbolically represented as shown in figure p-n junction diode under forward bias. If a suitable voltage is applied between the two ends of the p-n junction diode such that P side is connected to the positive terminal of the battery and N side to the negative terminal, the applied voltage mostly drops across the depletion region. If this external voltage becomes greater than the value of the potential barrier, approx 0.7 volts for silicon and 0.3 volts for germanium, the potential barrier's opposition will be overcome and current will start to flow. The width of the depletion layer around the p-n junction is decreased. Due to applied voltage, electrons from N side cross the depletion region and reach P side. Similarly, hole from P side cross the junction and reach the N side. This motion of charged carriers on either side gives rise to current. The resistance of this junction is very low. The drift current under forward bias is negligible, microampere, when compared with current due to injected carriers, which is usually in milliampere. p-n junction diode under reverse bias. When an external voltage V is applied across the diode such that N side is positive and P side is negative, it is said to be reverse biased. Electrons and holes are repelled farther from the junction and the depletion layer widens. The effective barrier height under reverse bias is V0 plus V. Only a few minority carriers cross the junction and a tiny current called the leakage or reverse current flows. The resistance of the junction is very high. The current under reverse bias is essentially voltage independent up to a critical reverse bias voltage known as breakdown voltage VBR. When V is equal to VBR, the diode reverse current increases sharply. Even a slight increase in the bias voltage causes large change in the current. The circuit arrangements for studying the VI characteristics of a diode, that is, the variation of current as a function of applied voltage, are shown. Diode under forward bias, diode under reverse bias. A graph between V and I is obtained as shown in figure. We conclude that the p-n junction diode allows the flow of current only in one direction under forward bias. The forward bias resistance is low as compared to the reverse bias resistance. This property is used for rectification of AC voltages.